And this is the second part of Chapter 4, where we are going back to equilibrium and solving for equilibrium algebraically. So if you happen to have your book, it's page 87. This is number 14, problem in the book. There are two equations for lines here. You might remember on the first day we said the equation for a line was y equals mx plus b. And this is the same equation here. They've just moved the constant in front of the minus 300p. So if you happen to have two equations for these two lines, for the demand curve and the supply curve, you know that at equilibrium we start where they cross. So what you could do is set these two equal to each other and then solve for price and plug it back in and get quantity. And you could solve it that way. Right. So we know that quantity demanded equals quantity supplied at equilibrium. So what we can do is set these two equations equal to each other, equals 1400.
That's got to be a minus between the 1600 and 300?
Yes. All right, so let's get all of our constants over to one side. That's 200 minus 300p equals 700p. Now let's get our variables over to one side. So that is just one line there. Then to solve for p, we divide by 1,000. P is going to be equal to what?
0.2.
Yeah, 0.2. So 20 cents. So, y'all see how to do this? It's the same exact thing that we've been doing. You can just identify where the equilibrium is on a graph by finding where they meet. We're just doing algebraically here. We're finding where these two lines meet by setting them equal to each other and solving for p. You just get all your constants on one side and you get the variable on the other side. So, is everybody okay with this so far? Okay, and what can you do to solve for q? Plug it back in here, and then you can double check yourself by plugging it back in here. Okay, so if we were to plug 20 cents in there, quantity, what do y'all get?
$15.40.
Okay, that's what I got, 1540. Okay, let's double check ourselves. 1400 plus 700 times 20 cents is equal to I'll get 1540 for this one also? Okay. Would everyone be okay with a problem like this on the test? Okay. Just put them, set them equal to each other, solve for P, plug it back in, and then solve for Q. Again, we're just finding where supply and demand meet algebraically. Okay. So let's come back here to past the curve shifting in our notes from chapter 4. Talk about when we have a double shift. So back to slide 26. When we've got a double shift now, we were just dealing with your homework and on the quiz we were just dealing with one shift. But on the test there will be one question where there's a double shift. In this case we've got a shift to the right in both supply and demand. So when both supply and demand shift to the right, remember, these are simultaneous shifts. So if you see a problem like this where two things are happening at one time, technology increasing and people are expecting the price of gas to rise tomorrow, so they're all filling up their tanks today. So two things happening at the same exact time. You're going to start out with those blue lines, set up your problem and graph just as usual. Okay, so draw a rightward shift of demand, that would be the red line, and then a rightward shift of supply, that would be the second red line. These are, pretend this is simultaneous, so you don't have to worry about the order. You're just going to have find where the two blue lines meet, that's your first equilibrium. Find where the two red lines meet, that's your second equilibrium. Okay, what happened to prices?
In this scenario, they went up.
In this scenario, they went up. Because here's our old price, here's 0, here's our new price. And then what happened to quantity? It has also increased. Here's 0, here's the old quantity, and our new quantity is going to be right about there. So even though we don't have numbers on here, we know that it's going to increase because 0 is over here. So in this case, quantity increased and price increased. But let's take a look here. And we've got two blue lines, supply and demand, that we're starting out with. And our two red lines here were both shifted to the right again. So demand increase, that's this red line, and supply increase, that's this red line. Okay, what happened to quantity?
Increased.
Increased from here, our old equilibrium where the two blue lines met, and here's the new equilibrium where the two red lines meet. Quantity increased, but now what happened to prices?
They decreased.
Okay, they actually decreased. What if there's actually one more possible outcome? What if I started out and pretend these are blue lines, supply, demand, price, and quantity? Like that. And then pretend these are the red lines. A rightward shift of demand, call that demand 2, and a rightward shift of supply. And draw a big dot right there. There's my second equilibrium. Here's my first equilibrium. Okay, now what happened to quantity? Here's my first quantity, here's my second quantity. What happened to it?
It increased.
Increased. What happened to prices?
Looks like it remained the same.
First price, second price. Stay the same. Okay, what is the one thing that we can say about these three graphs? In all cases, both supply and demand increased. But what was the one result that stayed the same? Quantity increased. What happens to price depends, right? I drew equidistant shifts. My graph isn't that great, but what I tried to do was draw equidistant shifts in both supply and demand. On this example, the supply shift was bigger than the demand shift, right? And then on the very first example that we were looking at, the shift in demand was bigger than in supply. So it depends on how far you shift each one in terms of what happens to price in this case. So all we can say, if there's a question on the test and it says, if supply and demand both shift out to the right, what's the only thing you can say for sure? Quantity will increase. And we said that what happens to price depends on how far we're shifting it out. But the word your author uses is ambiguous. And that's just a fancy way of saying it depends. Oops. It depends on how far you're shifting them out. It's unclear. We don't know for sure. That's what ambiguous means. Okay, I'll post another example in Blackboard where there's a double shift. But remember, it's simultaneous. So just draw your first supply and demand curve, and then draw your second supply and demand curve. Just find the new first equilibrium and the new equilibrium and then compare, just like we did together here. So everyone be able to look at a problem like this? Okay. There'll be one problem like that on the test, one problem on the test where there's an algebraic solution for the equilibrium. Okay, great. Now we're going to look at instances where we are not in equilibrium. All right, let's take a look at the textbook definition, then we'll look at an example. When the price is too high, basically it's saying when the price is too high, when the price is greater than the equilibrium market clearing price, quantity supplied is actually going to be greater than quantity demanded. Remember, at equilibrium, right where we have that dot where they both crossed, quantity supplied and quantity demanded are equal. Again, that seemed really obvious when we were looking at right where that X is and right where they cross. But now we're looking at instances where that doesn't happen. So that will lead to a surplus. If quantity supplied, that makes sense, right? So the amount that sellers are willing and able to supply at that price is greater than what consumers want to buy, then we're going to have some stuff left over. Okay. So, ice cream cones. Here's our market equilibrium. 7 ice cream cones are being sold at $2 each. Okay, and let's say that the price of ice cream has gone up 50 cents. So ice cream makers are thinking, well, we're selling 7 for $2 each. I bet we could sell more or maybe we could sell the same amount. Let's say they're thinking we could sell the same amount at $2.50 each, and we could make some more revenue. Well, what happens at $2.50? Sellers are happy. They're willing and able to provide how many ice cream cones at $2.50? 10. At $2.50, remember we're looking at the supply curve here. At $2.50, our suppliers are willing and able to sell 10 ice cream cones. At $2, they were willing and able to sell 7. But at $2.50, they're willing and able to sell 10. What about consumers? Are we as happy about high prices? No, I'm just looking at the demand curve because we're talking about consumers. At $2.50, consumers are only willing and able to buy 4. So there's a mismatch there, right? The market is not going to clear. Now at $2.50, how many ice cream cones are going to be sold? At $2.50, so you're just looking at this line.
4.
How many ice cream cones are going to be sold? Only 4. Only 4. Sellers, because that's all that consumers are willing and able to buy. Now, our sellers would have been willing to sell 10. So what does that mean? What does this represent right here? That surplus of 6 ice cream cones that are left over because they're too expensive and consumers are not buying them. So when prices are higher than the market clearing price, and there's a whole bunch of stuff left over, what does Walmart do when they have a bunch of stuff left over on their shelves? Okay, put it on sale. They start lowering the price to get us back down to equilibrium. So these ice cream sellers are going to realize pretty quickly that that price is a little too high. And if they're not going to want to bring home all this extra ice cream, they're going to have to bring down the price a little bit. So going back to what we have on this slide, suppliers, if they see that surplus, the price is going to come down. And we're getting back to equilibrium. We're going back to Adam Smith's idea of that there's this like invisible hand that brings us back down because sellers are going to realize that price is too high and they're going to have to lower the price to get rid of that surplus. On the other hand, if the price is too low, then the quantity demanded exceeds the quantity supplied. How many of y'all are musicians in here? Oh, okay, we've got, what do you play? Guitar. Okay. Do you play in a band? No, just for fun. Well, if you were to start your own band someday and you're playing somewhere, you've got a show, if your concerts keep selling out, you know that the price is too low. That means that customers really, really like your music and they would love to, they would be willing and able to pay a little bit more than the ticket price that you're charging. Okay, so here's equilibrium price and quantity again at $2 each for ice cream cones, 7 will be sold. If they're on sale for $1.50, consumers here are happy about that. They would be willing and able to buy 7 ice cream cones at $1.50. What about sellers? With a lower price, sellers aren't as happy. They're only willing and able to sell 4. So now we've got a shortage of how much? 6 ice cream cones. All right. When I ask you about the equilibrium price and quantity, just as usual, you're going to find where supply and demand meet. And you go straight down if we're talking about quantity, and you go straight across if we're talking about price. And you can write on your tests, you can write on your quizzes, and y'all draw these lines if it helps you. Yep. Oh, go back one chart. So when I'm asking about equilibrium, that's easy. That's what we did last time. When I ask you if the price was $1.50 or $2.50, what's going on there in terms of a surplus or shortage? Your answer as to how much of shortage we have here is 6 based on this number, and you ignore the 7 because that corresponds with the equilibrium price of $2.50, right? If I'm asking you about what is happening at $1.50, you find $1.50 and you go straight across, see where it hits supply, see where it hits demand, and then you're comparing these two numbers. You ignore this one. Okay? And so, again, just to sum up, economists think markets are a good way to organize activity because sellers are going to realize if they have extra stuff left over, they're going to need to lower the price to get rid of that surplus. They're going to also realize that they keep running out of stuff. Consumers are going to be upset because they're on a waiting list, they're not getting what they need, they're going to go find another seller to get what they want, that they'll have to adjust prices maybe upwards if they keep running out of stuff, that people are willing and able to pay more. And allocation of resources, that's a fancy way of saying who gets what. And prices in markets are the main signal, we said that before, and that determines who gets the products that we sell in our markets. Okay, and that's the end of chapter 4.